Well, now in problem number 4, we are told that we have an urn. Now an urn is like an olden days box. When probability started, people just talked about urns. So an urn, a box containing 12 numbered balls, 8 of which are red and 4 white. Now when I see these problems, what I do right away is I'll draw my urn and I will put in inside what we've got. So we have 8 red and 4 white balls. Now on the outside, I'm going to put the total number that we have, and then as I read a little further, a sample of 4 is to be selected. So we're going to select 4. So I'll draw the urn, and on the inside I'll put what I've got, my specifics. I've got 8 red, 4 white balls, and on the outside I'm just going to summarize what we're doing here. I've got 12 balls all together. I'm going to locate that, note that as N, and then R, this will be the number we select. R is the number 4 because we're going to select 4. Now in part A, we're just asked how many different samples are possible. So what we're doing here in this problem is that we are selecting from 12 balls altogether. We're just going to select 4. And when I compute that, I'm getting 495. Does that make sense now? We've got 12 altogether and we're just going to choose 4. There's no restrictions here, just how many samples are possible. Now for part B, we're asked how many samples contain all red balls. So I'm going to write that here. What I want here is the number of ways that we can get all red. So when I do these problems, I'm going to write it in English first. This gives me a little chance to have it go through my head and try to figure out what it is I'm looking for. So I'm thinking, how can we get all red? Well, to get all red, right, to get all red out of here, what I want is this. I want to find the number of ways that I can get 4 reds. That's going to be all red, but really what I want, I'm going to go one step further. If I get 4 reds, I'm going to get everything in terms of the reds and the whites. I want everything in this box accounted for down here when I start writing to get my count. So this is going to be the number of ways I can get 4 reds, but now let's include everything that's up here. If I get 4 reds, that's going to be and, intersection, 0 whites. And now that I've got this, everything is right in front of me and I can see what to write here. There are 8 reds altogether and we want 4 of them, right? So back in here in our urn, there's 8 reds. We want 4 of them. And, okay, this is an and, so that's a multiplication. And there's 4 whites, right? Back up here in our urn, we can see we've got 4 whites. And how many of those do we want? We want 0. Now that just turns out to be a 1. So I get 8 choose 4 times 4 choose 0. And when I compute that, I got 70. Now in part C, we're asked how many samples contain 2 red and 2 white. So let's see what we can do here. What we're trying to do is count the number of ways that we can get 2 red and 2 white. So this is going to be, well, let's see. We've got 8 reds from which to choose, and we want 2 of them. And the intersection, we have 4 whites, and we want any 2 of those. And when I make that computation, I came out with 168. Now, problems like this, part D, are going to come up often, where we're asked, how many ways can we get at least something? So we want at least 3 reds. So I'm going to write this in English. The number of ways I can get at least 3 reds, and then what I'm going to do is I'm going to take this at least and break this into exactlies. So the number of ways of getting at least 3 reds is this. To get at least 3 reds, we could get 3 reds or 4 reds. Right? We're choosing only 4, so how do I get at least 3? I could get 3 reds or 4 reds. But now, what I want to do now is I want to get these in terms of everything that is in this box. In this box, I've got reds and whites. I want these in terms of reds and whites. That will allow me to get to my count. So here's how I think we can do this. To get these 3 reds, I'm going to count this. the number of ways, I'm going to put a square bracket here so I can count everything. 3 reds, I could get 3 reds and 1 white. Does that make sense? What I'm trying to get is 3 reds, but I'm drawing 4 balls altogether. So to get 3 reds, I have to have 3 reds and 1 ball has to be white. And then here is an OR. So we're going to have an OR. See if I can get it there. OR. Now to get these 4 reds, and in terms of everything up in here, this is going to be 4 reds and 0 whites. Kind of like a problem we just did not too long ago. And now that I've got things written out in this detail, I can get my count. So how do I get this 3 reds and 1 white? Well, there's 8 reds from which to choose. We want 3 of them, and times there's 4 whites. We want any one of those. Now this is an OR, right? There's an OR, and an OR is a plus. And then here we have 4 reds, 0 whites, so there's 8 reds from which to choose. We want any 4 of them. There's 4 whites. We want none of those. So when I computed these separately, this one here is 224 plus this one here is 70. So altogether we're going to get 294 ways to do that.